again, everyone. We're back with part 2 to section 0.2. So I kind of wanted to split that up a little bit. So now we're getting into mixed numbers. So we haven't talked about those yet and what that is. So now we're getting into mixed numbers, okay? A mixed number is a whole number and a fraction, okay? So for example, this is something like 2.5, okay? Whole number and a fraction, 3 3/5, right? Whole number and a fraction, so that's a mixed number. So we're gonna be dealing with those, right? We're not always gonna be given a fraction that's a typical, right, proper fraction, or just a whole number, right? We're gonna be given a mixture as well, okay, mixed numbers. So the first thing we need to be able to do is, let's look at subtraction. And let's say they gave us 2 minus a fourth, okay? 2 minus a fourth. So no, this isn't a mixed number yet. Our answer is gonna become a mixed number, okay? So we're now dealing with 2 minus 1/4. So you have to think about this a little different. I can't just put the whole number 2 over 1. It doesn't work that way like it did when we multiplied and we divided. It doesn't work that way. We can only add and subtract fractions from other fractions, right? We have to have a fraction there. Right now I have a whole number and a fraction, and that doesn't work, okay? So we're gonna be using the borrowing method like you do if you were, subtracting whole numbers, okay? And another thing that I like to do is I like to make those vertical instead of horizontal. It's a little easier to see visually when we're gonna have to borrow, okay? So right now I have 2 minus 1/4. I need that fraction to subtract 1/4 from. So we're gonna borrow from the 2, okay? And that 2 now becomes a whole number 1, okay? Now I still have a fraction that when I simplify it will still give me, right, the whole number 2. So we're not changing the entire problem, right? We're just tweaking it a little bit. We're going to use the denominator that we already have. Don't make more work for yourself, okay, to where you're having to build equivalent fractions. Use what you have. You have a denominator 4. This now becomes 4 over 4. So also remember, fraction problems are division problems. So 4 divided by 4 is 1. 1 plus 1 is still 2, okay? That's where this is all coming from. Now we can subtract, because I have 4/4 minus 1/4. The denominators are the same. They're both 4, so we can subtract. 4 minus 1 is 3. It stays over the 4, and I can bring my 1 down. 1 3/4 is our answer. Double check, see if you can reduce. We can't. We're done on this one, okay? Let's do another. Let's do another. Let's look at 5 minus 2/3, okay? 5 minus 2/3. So once again, I need that fraction to subtract from, okay? And right now I don't have it. So I want to go ahead and set my problem up vertically. Easier to visualize. And then we're going to be borrowing from the whole number 5. So I'm borrowing from the 5. I'm subtracting 1 from it. So that makes it a 4. Now I want to go ahead and analyze the denominator. We already have a denominator of 3. Let's use it, okay? And now we're going to make the fraction 3 over 3. So remember, 3 divided by 3 is 1. 1 plus 4 is still 5. So I'm not changing the whole problem. I'm just tweaking what that number looks like a little bit. So now we can subtract 2/3. We have a common denominator of 3. We're good. So now I can do 3 minus 2 is 1. Stays over the denominator of 3, and I can bring down my 4. 4 1/3 is your answer there. Okay? Things get a little different when this isn't a whole number and this is a mixed number. So we're going to do some examples of that now. So like I said, if you have problems with this, please message me so we can do some further explanations. And remember, you can rewind this video, watch it as much as you need to. Look at examples out of your book, read the book, plus you have these notes written out in PDF form. Okay, so let's go ahead and do 4 1/4 minus 3 2/3. Okay, 4 1/4 minus 3 2/3. Well, right now I have two fractions, which is great. Okay, that's already set up for us. But right now I can't subtract them, right? I have 1/4 minus 2/3. Well, they don't have the same denominator, and you have to have a common denominator. So the first thing we want to do on the side is we want to come up with an LCD for 4 and 3. So our LCD would be 12, okay? Would be 12, and then we're going to build those equivalent fractions. So we have 1/4 equals blank over 12. We do our circle method, so 12 divided by 4 is 3. 3 times 1 is 3, and I do the same thing with 2/3 equals blank over 12. Circle method, moving in the left direction. 12 divided by 3 is 4. 4 times 2 is 8, okay? So now I have 4 3/12 minus 3 8/12. Now, I'm dealing with fractions. I can't have negative numbers with fractions, right? So if I did 3 minus 8, I'd end up with a -5, and that doesn't work when we're dealing with fractions, right? Think of having a pie. I can't have negative pi, right? I'm going to have a whole pie that I can deal with, okay? So now we're going to use that borrowing method that we just did before. I'm going to borrow from the whole number 4, and I'm going to make it a 3. We already have a common denominator of 12, so it's the same thing as before. This is going to be 12 over 12, right? 12 over 12 is 1. 1 plus 3 is still 4. But you can't forget, I already had a fraction with the original problem that was 3/12. I can't forget that. It's still there. It's still part of the problem. So you're going to add these two fractions together. So I still have a whole number 3. I'm going to do 12 plus 3 to give us 15. Stays over our 12. Okay, stays over our 12. All right. We're still subtracting our 3 8/12. Oops. Minus our 3 8 over 12. There we go. Looks better. I have terrible handwriting. Okay, so now we can go ahead and subtract. So I can do 15 minus 8 to give us 7, stays over 12. Now the whole numbers, 3 minus 3 is 0. So 7/12 is our final answer, okay? I would study this problem, practice this problem. You can find more examples in your book, more practice problems in your book. Also, if you notice in the textbook, I try to always give you odd problems for homework, because the answers are in the back of the book. You can check the odd answers in the back of your book, okay? Even if you did an online version, an ebook version, you can still get the answers as well. Every once in a while, I will give you an even problem that you won't have the answer to, but you can always message me and double check to see if you're getting the right answer, okay? But there's more of these you can practice in your book besides what I'm giving you for homework, which isn't a whole lot. Okay, I only give you guys 10 questions a section, right? We're dealing with a lot of stuff in this section, so you're only going to have a couple problems of each. So I would definitely practice problems so you're ready for your test. Okay, let's do another. Let's do 10 1/5 minus 7 3/5. Well, what's great is we're going to go ahead and check. See if we have a common denominator. Well, we do. They both already have a denominator of 5, so I get to eliminate, the steps we had to do before with building equivalent fractions. But I can't do 1 minus 3 when I go ahead to subtract the fractions, right? So we're going to have to borrow. So I'm borrowing from that 10, and it's becoming a 9. Use your common denominator. We have 5, so this is now 5 over 5. So 5 divided by 5 is 1. 1 plus 9 is still 10, okay? But I still have this fraction of 1/5 that isn't going anywhere, so you need to add that so that we have 9 6/5. Okay? Still subtracting the 7 3/5, okay? So now I can subtract. I have a common denominator. I can do 6 minus 3 is 3. It stays over 5. And now I subtract the whole numbers. 9 minus 7 is 2. Double check to see if you can reduce that, and you can't, right? So it's 2 3/5 is your final answer, okay? All right. Now that we did subtraction, right, we need to be able to add these together. So adding's a little easier. So let's look at 2.5 plus 5 2/3, and I like to do those vertical as well. Just makes it a little easier and neater to deal with, okay? So same thing with subtraction, right? We need to have a common denominator for addition. So the first thing you're going to do is, do they have a common denominator? 2 and 3. No, they're different. So you're going to find the LCD first. Well, for 2 and 3, it ends up being 6. Okay, it ends up being 6. And if you need to work that out on the side like we did before, that's totally fine. Now we're building equivalent fractions. So I'm going to take my 1/2 equals blank over 6. Moving in the left direction, we're dividing. So 6 divided by 2 is 3. 3 times 1 is 3. So this is now 2 and 3, 6. Plus, well, we need to figure out 2/3. So now I have 2/3 equals blank over 6. Moving in the left direction, we're dividing first. So 6 divided by 3 is 2. 2 times 2 is 4. So I have 5 and 4, 6. Now I can add 3, 6 plus 4, 6. Well, 3 plus 4 gives us 7, stays over 6. 2 plus 5 is 7. So we haven't dealt with this yet, that improper fraction. So more times than not, you're not going to be able to leave an improper fraction, especially when dealing with mixed numbers, okay? So right now that 7/6 is telling me I have more than 6 pieces, okay, that denominator. So you're going to turn this into an improper fraction, okay? So you are turning now an improper fraction to a mixed number. How you do that is by dividing, right? Fractions are essentially division problems. You are going to divide, and this is telling you exactly how to do it. This is 7/6. It's saying 7 divided by 6. So 7/6 is telling you to do 7 divided by 6, okay? And you're going to do this longhand, right? Long division. Calculators don't do it for you. So we have 7 divided by 6. So we're going to divide longhand. 6 goes into 7. 1 times 6 is 6, and you subtract, you're left with a remainder of 1. So you may remember at school at some point doing, you know, R1, right, for the remainder. We're not doing that. We're dealing with fractions. So your remainder becomes the numerator of the fraction. What you divided by is the denominator. So the 7/6 turned into 1 1/6. Now what you have to keep in mind is we had a whole number 7 already. So you're going to add the whole number 7 and the whole number 1 together to get a final answer of 8 1/6. You may want to study this type of problem. This is going to come up again, okay? So you may want to go ahead and study that. All right? Okay. All right, let's look at some more stuff. I told you it's a very, very long section. Let's go ahead and do, let's change 14/3 into a proper fraction, sorry. Into a proper fraction, okay? So we just did this. This means division. You're going to divide exactly how it's given to you. 14/3. That means 14 divided by 3. Don't flip-flop it. Do it exactly how it's given to you. Don't do 3 divided by 14. You're going to get a crazy decimal. 14 divided by 3. So 3 can't go into 1, but it can go into 14 4 times. 4 times 3 is 12. Subtract, you're left with a remainder of 2, right? This is something you should have been doing for a long time. 2, your remainder, becomes the numerator. What you divided by becomes your denominator. Look to see if you can reduce further. You can't. So 4 2/3 is your final answer. Okay? All right. Something else that you have to be able to do with these problems is to change mixed numbers. So we are now changing mixed number into improper fractions. We need to be able to do this to multiply and divide mixed numbers, okay, which is what we're going to get into next. So this is my second circle method that I'm going to teach you. This is the second circle method. It's different. You need to study the difference between the two. All right, so we're doing a circle method. We're going in the left direction, okay? This time, we are multiplying the denominator times the whole number. So you are doing 4 times 3 gives me 12. Then you are adding the numerator. You are adding 2 to get 14. Then that becomes the numerator. It stays over whatever the denominator originally was in the problem. So 4 2/3 becomes 14/3 as an improper fraction. Okay? Let's do one more of those and let's get into multiplication and division. Let's look at 3 1/5. We want to change it to an improper fraction. Circle method to the left. You are multiplying. 5 times 3 is 15. You are adding the numerator. So 5 times 3 is 15 plus 1 is 16. It stays over the denominator 5. So 16/5 is your answer. Okay? Don't do anything else to it. That's your answer. The reason why this is so important is because when you are multiplying and dividing mixed numbers, remember, you can only multiply and divide fractions by fractions. So if you're given a mixed number, those are not fractions, right? It's a whole number and a fraction. So that's why you need to know how to do this. So let's say they gave us 2 2/3 times 4 1/4. Okay? 2 2/3 times 4 1/4. We have to turn both of those into fractions. I cannot multiply how they're given. It doesn't work that way. So we're going to change 2 2/3 into an improper fraction. So in the left direction, we're doing 3 times 2 is 6, plus numerator 2 gives us 8, stays over the denominator of 3. Multiplied by 4 1/4. Again, it's a mixed number. We need to change it to an improper fraction. So in the left direction, we're multiplying. 4 times 4 is 16, plus the numerator of 1 gives us 17, stays over the denominator of 4. That 4 doesn't change. Remember, multiplying and dividing, we don't care what the denominators are. It only matters with addition and subtraction. Now, we're going to apply our rules of multiplying fractions. So we're going to look diagonally. Does anything cancel? Well, the 3 and 17, nothing goes into both, no common factors. But when we look at the 8 and 4, 4 is a factor of both. So 4 divided by 4 is 1, 8 divided by 4 is 2. Now we can go ahead and multiply straight across like we did before. So we have 2 times 17 to give us 34 over 3 times 1 gives us 3. Now, sometimes they're not going to tell you to turn that back into a mixed number, and that's fine. If they don't say turn it back into a mixed number, you can leave this as long as it's reduced, okay? So it just means that there's no number that goes in the numerator and denominator. Sometimes they're going to say answer must be as a mixed number. Then you're going to use the rule we just did with division. Then you're going to do 34 divided by 3, exactly how it's given. You're going to do this longhand. So 3 goes into 3 one time. 1 times 3 is 3. That becomes 0. Remember, you drop down the second number, okay? Drop down the 4. 3 goes into 4 one time. 1 times 3 is 3. Left with a remainder of 1 now. 1 becomes the numerator. 3, what you divided by, becomes the denominator. So, depending on what they ask, it could be 34/3 or 11 1/3 as an answer. Okay? All right. Another way they could be giving these problems to you is a mixed number and a whole number. Okay, so let's do an example like that. So they could give you 5 2/7 times a whole number 2. So same thing, you can only multiply fractions by fractions. So we need to turn 5 2/7 into an improper fraction. Okay, so we're doing the circle method. The second one, we're multiplying. 7 times 5 is 35. Plus 2 is 37/7 times. Well, now I have a whole number. Remember, to turn a whole number into a fraction, all you do is put it over 1. Okay? All right, and from here, you're going to look diagonally and see if there's any common factors to simplify. In this problem, there are not, so we're going to multiply straight across. So 37 times 2 gives us 74 over 7 times 1 is 7. That's an improper fraction. So if they want it turned into a mixed number, divide exactly how it's given. So then you would do 74 divided by 7. Okay? 7 goes into 7 one time. 1 times 7 is 7. You subtract, you're left with 0. You bring down the 4, right? From here, 7 into 4 can't happen. We can't do it. So this becomes a 0. 0 times 7 is 0. So you're left with the remainder of 4. 4 becomes the numerator. 7, what you divided by, is the denominator. And 10 4/7 is your answer. Okay? There's another one of these in your notes if you need another one. Okay, another example to look at. Let's look at division. We looked at multiplication. Let's look at dividing. Dividing mixed numbers. So let's look at 5 2/7 divided by 2 2/7. So once again, we can only multiply and divide fractions by fractions, right? And right now I have 2 mixed numbers. So we need to turn these into improper fractions, okay? So we're using the second circle method, moving in the left direction. We're multiplying first. So 7 times 5 is 35, plus 2 is 37, and it stays over 7. Divided by, well, I have 2 2/7. Once again, it's a mixed number, so we need to turn it into an improper fraction. Moving in the left direction, we multiply first. 7 times 2 is 14, plus 2 gives us 16. It stays over the denominator 7. Now we are dealing with division of fractions, right, which we did before. Hopefully you're becoming very comfortable with. Apply our rules. First fraction stays the same. Division becomes multiplication. We flip our second fraction. Okay? Now we're dealing with multiplication. So we apply our multiplication rules. Look diagonally. Are there any common factors that we can simplify? There's nothing for 37 and 17, but the 7s cancel, right? 7 divided by 7 is 1. 7 divided by 7 is 1. Now we can multiply straight across. So 37 times 1 is 37. Over 1 times 16 is 16. We're left with improper fraction. If it says to turn it to a proper fraction, that's when we need to, not proper fraction, a mixed number. If it says turn it to a mixed number, that's when we need to divide exactly how it's given, 37 divided by 16. So we would do our side work, 37 divided by 16. 16 doesn't go into 3, it goes into 37 2 times. 2 times 16 is 32. And then you subtract. 37 minus 32 gives us the whole number 5. 5 is the remainder. It becomes the numerator of the fraction. What we divided by, the 16, becomes a denominator. Double check to see if that reduces. It does not, so that is your answer. 2 5/16. Okay? Sometimes it is not just going to be two mixed numbers together. It may be a mixed number and a whole number. So let's do an example like that. Let's look at 6 7/8 divided by 5. 6 7/8 divided by 5. So once again, with division, you have to divide a fraction by a fraction. That's a mixed number. So we're going to use our second circle method to turn it into an improper fraction. Multiply first, 8 times 6. Then you're going to add 7 to get 55 over 8. Divide by. Well, I have a whole number 5. I have to turn it to a fraction. Remember, to do that, this becomes 5 over 1. Okay? Now we can apply our division rules. First fraction stays the same. Division becomes multiplication, and we flip our second fraction. Okay? Now we apply our multiplication rules. Look diagonally. Do we have any common factors? The 8 and the 1, we do not, but 5 and 55 we can simplify. 5 goes into 5 one time. 5 goes into 55 11 times. Now I can multiply. 11 times 1 is 11. 8 times 1 is 8. Now I have 11 over 8. That's an improper fraction. Let's turn it back into a mixed number by dividing. So you're going to do it exactly how it's given. 11 divided by 8. 8 can't go into 1, but it can go into 11 one time. 1 times 8 is 8. Subtract. 11 minus 8 is 3. 3 becomes your numerator. You divided by 8. So that's your denominator, 1 3/8. Okay, and that does not reduce, that does not simplify. Okay, so that's your final answer. All right, so that is adding, subtracting, multiplying, and dividing mixed numbers. So we are officially finished with section point 2. It's a lot of material, but hopefully this is all, stuff you've done before. It's coming back. Hopefully remember it. When we get into section point 3 and point 4, we're dealing a lot with decimals and percentages. We'll deal a little bit more with fractions. And then chapter 1, we'll start getting into some more of the algebra. Okay? Like I said before, if you have any questions, please let me know. Make sure you follow the instructions that have been provided to you on Canvas, okay, and the welcome letter, as well as how to do your homework and how to complete the test. And if you need me at all, please send me a message. All right, thanks guys.